Hello and welcome to another video. This is Cracking the Cryptic app, Fog of War pack, puzzle number 15. It is an unnamed puzzle, but it is actually a favorite of mine. I think it's a very beautiful puzzle. The rules are: Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column, and box must have all numbers from 1 to 9 exactly once. Partial Kropki. A white dot between two cells indicates that the neighboring digits are consecutive. A black dot between two cells indicates that one of the digits is twice as big as the other digit. Not all possible dots are given. Region sum lines. Digits along the blue path have an equal sum n within each box it passes through. If the path passes through the same box more than once, each individual segment of the path within the box sums to n separately. We also have a custom rule. Every line is a region sum line. Each line is a unique color and only moves orthogonally from cell to cell. A line does not branch and does not intersect with itself or other lines. Each line contains every digit from 1 to n exactly once, where n is the length of the line. Before we begin, I think it would be good to revise the rules a little bit because I don't think these rules are very popular, and with the custom rule especially, it would do good to explain everything properly. So first, let's see the most important rule and the most important clue we have. It's that each line is a unique color. So since we see the ends of a line, which is the same color, that basically means that this is one line. I've selected one path that this line could possibly take, and we don't know if this is the path that it does take, but I'm just going to color it, and we're gonna explain the rules using this path. We're gonna assume that it is this path while we are explaining the rules. It says a line does not branch and does not intersect with itself or other lines. That should be self-explanatory. Each line is a unique color and only moves orthogonally from cell to cell. Basically, that means that it can go up, down, left, right. It just does not go diagonally. Each line contains every digit from 1 to n exactly once, where n is the length of the line. So, since we've colored in 1, 2, 3, 4, 5 cells, that must mean that this line contains all numbers from 1 to 5. That's basically what the rule says. So if it's 7 cells long, it would basically mean that the maximal number it can take is a 7, and it contains all numbers lower than 7. Now, if we go down, we've explained the custom rule pretty all right. And now if we go down and check the region sum lines rule, digits along the blue path, obviously the path doesn't have to be blue because we were told in the custom rule that every line is a region sum line and they're all uniquely colored. So digits along the blue path have an equal sum n within each box it passes through. If the path passes through the same box more than once, each individual segment of the path within the box sums to n separately. So there is some sum that each segment sums up to. That's basically what it means. So with that in mind, we can immediately start reasoning about this current path that we assumed that the line took. Well, that would mean that the four selected cells that I just highlighted sum up to the same thing as this thing on the right. But how would that be possible? This region on the right is just one cell long. So the only value, the maximal value it can take is a 5. And the minimal value of the 4 cells on the left is 1, 2, 3, and 4, which sums up to 10. So obviously they don't sum up to the same value, so region sum lines rule is violated. Therefore, it means that this is not the path that the line takes. And in fact, we know for sure only one thing. We know that the line goes to the left over here and that it goes to the right over here. Now, we could assume that the line goes further left, but that just makes it harder for the line to go back right and down and here. So it could go like this, but that just further violates the region sum lines rule. It makes it harder to satisfy that property, and it was already impossible. So that must mean that this is not where the line goes. It doesn't go more to the left. It actually goes downwards and to the right. Because, as it said, if the path passes through the same box more than once, each individual segment of the path within that box sums to n separately. So that means that these two must sum to some value n, instead of requiring that all four of them do that. So going back saved us. All right, so now the line must loop, right? It must go like this, or it goes straight like this. And in both cases, it does go through the square. So either it goes like that, or it goes straight down. And in the first case, if it went through these two squares, then let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be the maximum length that the line is allowed to be. So in that scenario, the line would contain all numbers from 1 to 9. Let's assume that this is the case. Well, if that's the case, what value can this square be? This square is a region by itself, right? It's a single square region. And if it contained any number other than 9, for example, it was an 8 or a 7 or a 6, then the 9 would have to be somewhere else here, because as the custom rule said, all numbers from 1 to n have to be on the line and the digits don't repeat. So since it would be somewhere else, that would essentially mean that that region, because it has a 9 and this cell doesn't, this region would not be able to sum up to whatever that region that has the 9 is. And therefore, that's a contradiction. So it only makes sense to put the highest digit in this single cell. So this would have to be the 9. All right, so we now know that since a single cell region sums to 9, every other region sums to 9 as well. Because in region sum rules, right, every region sums up to the same thing. So this is a 9, this is a 9, these four are a 9, and this is a 9. However, we know that the digits along the line sum up to 45 because they're all 1, 2, 3, 4, 5, 6, 7, 8, 9. But 45 is just not divisible by 9 into 4 equal parts. And therefore, since we do have 4 equal parts, this does not work. Therefore, the region sum rule is violated, and the assumption that the line is 9 squares long leads to a contradiction because these two squares cannot be a part of the line. Therefore, we are back to the only other possible configuration where it is in fact 7 squares long going down like this. So 1, 2, 3, 4, 5, 6, 7. And try summing up these numbers and you'll see that you have 1, 2, 3, 4, 5, which sums up to 15, plus 6 is 21, plus 7 is 28. Okay, so we have a 28. And as we've reasoned previously before, this cell must have the maximal value, right? Because if it didn't, then the 7 would have to be somewhere else, which would make that region sum up to more than whatever the single cell region is. So this has to be the 7. And then each region has to be a 7. But 28 is divisible by 7. It's just 4. And we do have 4 regions. Here's 1, here's 2, here's 3, and here's 4. So it would work. So now we can select every other possible square in the grid and fill in every other possible value that they can have. Because that's going to make it a little bit easier for us. 7, 8, and 9. So this must be the 7 as we've reasoned. And every other square must, every other region must sum up to 7. So there's no repeats allowed, so this cannot be a 7. And since we see a black Kropki pair, this cannot be a 5, 7, or a 9, because nothing doubles into these values, and the double of their value is over 9. And we see that two cells along this line, which sum up to 7, are consecutive. So that must be the 3 and 4. So this is the 3 and 4. And since numbers cannot be repeated on a line, then this and this are now 3 and 4. Okay? And now, since these two are consecutive, then this is either a 2 or a 5. All right. So 3, 4 cannot be anywhere here. And let's look at this. All cells here cannot be 1, 2, 5, or 6, because 1, 2, 5, 6 is here. It's a quadruple. So 1, 2, 5, and 6 are not allowed to be there. Can an 8 be here? No, because there is no 4 here. So this cannot be an 8. Okay. Can a 4 be here? Well, if that was a 4, then this would be a 2 because of the double Kropki. So you would not have a 4 or a 2 over here, making that a 3, 5, but they're not consecutive. So that must mean that the assumption that this is a 4 leads to contradiction. So this cannot be a 4. So this is a 3, and therefore this is a 6. 4, they're consecutive, so this is a 5. This is the 3. And now that basically means that this up here, so since these two are a region, they must sum up to 7, so this is the 1. And now we have a 2, 5 pair over here. So there can be no 2 or 5 anywhere there. All right. Now, this revealed black Kropki pair, so these cannot be 5, 7, or a 9 because nothing doubles into those values, and the double of their value is over 9. And it also cannot be a 3 because, as we see, a 6 is up here. So they're either 2, 4, or an 8. So what we do see now is a green line. And the green line goes like this, and it goes like this. Since it's the same line, they must eventually meet, right? So let's first assume that the line goes down like this. That would make this 1, 2, 3, 4 squares long. 5, 6, 7, 8, 9. So it's too long because it must be at most 9 cells long, because it must contain digits from 1 to n, where n is its length. So at most it can be 9 cells long. So it doesn't go down. Therefore, it must go to the left. 1, 2, 3, 4, 5. Let's assume that it goes to the left. 6, 7, 8, 9. So the minimal length of the line is actually 9, which is also its maximal length. And since the minimum and the maximum coincide, that is its actual length. It is 9 cells long. Except that we just don't know if it goes like this or like this. So let's count again. 1, 2, 3, 4, 5, 6, 7, and then this is the 8th. It must go here, and then it's either snaking up like this or going down like this. We don't know for sure, so we're gonna leave that up for interpretation. But we do know that it is exactly 9 cells long, and therefore it contains numbers from 1 to 9. And since it contains all the numbers from 1 to 9, that means that the whole line sums up to 45. And we see that it has 3 regions. Here's the one region. Here, here or here is the second region, and this is the third region. So each region must be summing up to 15, because all regions must be equal, as per the region sum rules. So therefore, this must be 15. But as we can see, it does not contain a 6. Therefore, it must not contain a 9. And it's only 2 cells long, so it cannot contain the 4, and therefore that's the 7, 8. And since lines cannot contain same digits twice, all along the line, if we just follow the known places where the line goes, we cannot have an 8 or a 7. Okay. Let's assume now that the 9 is somewhere here. So it's either in this configuration or in this configuration. We're assuming that the 9 is on the line in box 4. Well, if it was, then that means that the other 3 digits would be 1, 2, and 3, right? All right. So that must mean that this is 1, 2, 3, 9, or this is 1, 2, 3, 9. In either cases, what value could this square have? Well, it's not a 9, it's not a 3, it's not a 1, therefore it must be the 2. And therefore, this must be a 4. So since we've used up 7, 8, and we've used up 1, 2, 3, and 9, right? That must mean that the digits that are left over for this square are 4, 5, and 6. And that's what makes the 15 in this region. However, a 4 can only be over here. And we've placed the 4 here, meaning that this cannot be the 4. So now there is no way to place the 4 here, and you cannot have 4, 5, 6 in this region, which is a contradiction. Therefore, the 9 cannot be on the line in box 4. So we're going to go all the way back to that assumption. And we are going to know that this cannot be the 9. Therefore, this is a 9. Somewhere here must be the 9. Okay, 15 minus 9, that's a 6. So the other 2 cells must be summing up to a 6. And there's only 2 ways you can really do that. You can have 5, 1, or you can have a 4, 2. But if you had a 2, 4 anywhere here, right, in any configuration, well, because digits cannot repeat along a line, then this square would be empty because it can only contain a 2 or a 4. So that must mean that this cannot be 2, 4, 9. It must be 1, 5, and 9. That's the only other choice you have. So this cannot be anything except 1, 5, and 9. Therefore, nowhere else along the line can you have 1, 5, or a 9. Okay. Now, that must mean that this thing over here must be 2, 3, 4, 6, either in this configuration or in this configuration. And in both cases, that must mean that 2 and 4 are on the line. 2, 3, 4, 6, right? So 2 and 4 are both on the line. So therefore, this cannot be either a 2 or a 4. And that's the 8, and therefore, this is the 4. So on the line, you must have 2, 3, 4, 6. And therefore, this cannot be 2, right? 1 second, my bad. This cannot be a 1, a 5, a 7, or a 9. So that's a 2, 6, because on this line, you must have 2, 3, 4, 6, right? So since we have a 2, 6 pair, that must mean that there is no 2 or a 6 anywhere else, leaving this square to be the 3. All right? And now, that must mean that 2, 6 is nowhere here. 2 or a 6. Perfect. 7, 8 is up here, meaning that these cannot be a 7, 8. And that makes a 4, 9 up there. So there is no 4, 9 in this row. All right. Now, 2, 6, 2, 6 means that this must be the 5, and then that's the 2. All right. So, can either of these digits be a 9? Let's assume that the 9 is here, in this region. If this is a 9, then that means that this blue line must be 9 cells long, right? So that must mean that it sums up to 45. So what value could it have in the square on the left? It can either be a 1 or a 7. Let's assume that it's a 1. That must mean that this region is a 10. Since the whole line sums up to 45, that must mean that each region divides up the line into regions of 10. But 45 isn't divisible by 10. That doesn't work. So this cannot be a 1. Can it be a 7? Nope, because that will make a 16. And 45, again, is not divisible by 16. You cannot have any number of equal parts of 16 that sum up to 45. So the region sum rule is violated. Therefore, this on the right side cannot be a 9. What about this thing on the left? Can this be the 9? Well, again, it cannot be a 7 here, because the 9 would, again, since it contains a 9, it would be 9 cells long. And that would make this a 16, and 16 is not something that can be added up any number of times to get 45. What about a 5? Can this be a 5? Well, together that will make 14, and 5 isn't divisible by 14 either. So for the same reason, that doesn't work. Therefore, the 9 cannot be here either. So 9 is somewhere here. And therefore, 9 cannot be anywhere on this line. So that's a 4 up there. Oops, that's a 4. And then this is the 9. All right. Can this value right here be a 7? Well, if that's a 7, then this must be the 1, right? It's forcing it to be a 1. And since we have a 7 on the line, that must mean that the line is at least 7 cells long, but it could have an 8 somewhere down there, right? Or it could have a 9 somewhere as well. So it is at least 7 cells long. And it sums up to 8. So 1 plus 2 plus 3 plus 4 plus 5 is 15, plus 6, 21, plus 7 is 28. 28 is not divisible by 8, so that doesn't work. It cannot be exactly 7 cells long. What about 8 cells long? 28 plus 8 is 36. 36 also isn't divisible by 8, and neither is 45. So that must mean that 8 cannot be how much a region is. Therefore, the assumption that this is a 7 goes to a contradiction, and therefore this is the 5. Since we have a 1, 9 over here, which is a pair, we cannot have a 1 anywhere here. Oops. We cannot have a 1 anywhere here, making this a 7. And now we know that the sum is 12. All right. So the 12 does actually work, and let's see when. So let's assume that the line is 7 cells long. That would mean that it sums up to 28. 28, however, isn't divisible by 12, so that doesn't work. So it must be more than 7 cells long. Let's assume that it's 8 cells long. Then it's 28 plus 8 is 36. Now 36 is divisible by 12. It's 3 times 12. So that will work. What about 45? Nope, 45 isn't divisible by 12. So that must mean that there are exactly 3 regions, each summing up to 12, and 8 is the highest number on the line. All right. So the line does go something like this. We're not going to use the blue color. Actually, Yeah, we can. All right, so it goes like this at the very least. Now, let's assume that 8 is not a part of this, of these two squares. Let's assume that the 8 is not here. So this is 1 and 4. Together, they sum up to 5. A 9 cannot show up on the line, right? That's what we said already. And it cannot go down here either because 1 and 4 is a 5. The only value this could have is an 8 because 1 and 4 is taken, which would be 13. That's greater than 12. It cannot go to the left because it can only get a higher value than 12. And therefore, it must snake to the right. So 1 and 4 is 5. Can it be a 7 immediately to get to 12 and then you get into another region? Well, no, because numbers cannot repeat inside the region and we already had a 7. So if it's snake to the right, which is the only option it has under this assumption, then it cannot be a 7 over here. It can either be a 3 or a 9, but as we said, 8 is the max limit. It cannot be higher than 8. 8 is the highest number that shows up on this line because it sums up to 36. So 9 cannot be there. Therefore, it's the 3. And now it must snake downwards because 1 plus 4 plus 3, it's an 8, right? It's not enough to be at 12. So it must go down, but it can only take the value 7. And 8 plus 7 is 15. That's not 12. So that doesn't work. The assumption that an 8 is not here, that an 8 is not in one of these two cells, that leads to a contradiction. So this cannot be the 8. All right. Since we know an 8 is here, that must mean that the 4 is not here, because if a 4 was anywhere there, 8 and 4 would yield 12 immediately, and we see that we do have to enter a third region in order to make the region sum lines work. So a 4 cannot be here, or it would yield too high of a sum too early. So this is 1 and 8. And since we have a pair of 1 and 8, that must mean that this is the 4. And now we see exactly the way it snakes. It snakes to the right. And since this is a 9, then this must be the 3. Now, the only cells we have, the only digits that we haven't used are 2, 4, and 6. And that's what must show up in this third box. It must be 2, 4, and 6 on the line. We don't know where the line goes. We see that it goes up to here and then to here. But we don't see the final cell. We don't see the way it curls. Maybe it goes up, maybe it goes down, maybe it goes right. But we do know that these cells, these two, cannot be anything except 2, 4, and 6. So, and we also know that these cells, which cannot be on the line, cannot be 2, 4, and 6, because 2, 4, and 6 are on the line. Okay? What else? Now, these can only be a 1 or a 5. They cannot be 8, 9 because they're consecutive. And now we have a 1, 5, 9, which is a triple. So it means that this cannot be 1, a 5, or a 9. And therefore, that is the 8. And now we see that this actually goes all the way here, which means that this is the 2, 4, 6. So this cannot be 1, 5, 7, or a 9. That's another 2, 4, 6. And also here on the right, it cannot be a 2, 4, or a 6. Okay. Or here on the left, it cannot be a 2 or 6, so that makes it a 5. So this is the 1, and then this is the 8. 8. Okay, I'm going to get rid of the blue color and of the green color and the red one, because at this point they are just a bit distracting. Now, we do have a black Kropki pair, so these cannot be 5, 7, or a 9. And this is a 159 triple, meaning that these cannot be 1, 5, or a 9. This is 179 triple, meaning that this cannot be 1, 7, or a 9. And this cannot be an 8 because there's no 4 up here, so this cannot be the 8. Okay. Now, this is either 5 here or 5 here. There's no other square that can contain the 5, right? So that means that the 5 cannot be down here. This must be the 1. And since they're consecutive, this is the 2. And so this is the 6, meaning that a 3 cannot be in the Kropki. If this is a 2, then this is a 4, and if this is an 8, then that's a 4, so this is a 4. And so this is a 4, and this is the 6. All right? A 5, 9 cannot be anywhere up here, because we have a pair, so this is the 1. Now, it's probably time to go slowly through the digits, just to make sure that we don't miss anything. So, these are the 1s, the 2s, okay, the number 3, the number 4, 5, 6, 7. So a 7 is either here or here, meaning that a 7 cannot be down here. 7, 8, or a 9. All right. So we are given another line. This is an orange line this time. And again, we have a single cell right here. So can this cell possibly be the number 3? Maybe. Probably not, because if it's a 3, then that would mean that each region sums up to 3. And as we can see, because this is one region, and as we can see, the lowest value here, if this is a 3, is 2 and 7, which is not 3. So this cannot be a 3. Can it be a 9 though? That's the highest value, so let's assume that's a 9. So this region would have to sum up to a 9. And there is no 6 to be paired with the 3, so this cannot be a 3, 6. There is no 1 to be paired with the 8, so it cannot be a 1, 8. So that would be a 2 and 7, because it has to sum up to the same thing as this region. But if this was 2 and 7, then this cell would be empty. Therefore, this cannot be a 9, and it can only be a 5. So that must mean that this is a 2 and 3. Oops, 7, 8, that's 2 and 3. And then this is the 7. And then this is the 8. So now we see the absolute length of this. 1, 2, 3, 4, 5. Obviously, that is 5 cells long. And this can only be a 1 and 4. And since this thing cannot contain a 1, then this is the 1, and this is the 4. All right, so then this is the 2. That's a 9. A 3 is over here, so then this is the 9. This is a 7. 9, 3, 7. 9 up here. 1, 5, and 9. And that's some good progress. Okay. Let's just quickly go through everything just to make sure Nothing too obvious is left. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Now, if this thing was a 9, you would run into a problem. Why? Because then you would have a line that has 9 cells, so it would sum up to 45, and it would need to be divisible into segments such that each segment sums up to a 9. But you would need 5 segments for that, because 9 times 5 is 45, and we obviously cannot fit that many segments in here. Well, if that was an 8, then you would need to have a cell that is at least 8 cells long, so it would sum up to either 36 or to 45, and it would need to be divisible by 8. But neither 36 nor 45 are divisible by 8, so this cannot be the 8. So that's either 2 or a 3. Let's assume that that's a 2. Well, if that's a 2, then there's just no way you can make this work, right? Because then it would need to be 2 and the 1, right? Because it must contain all cells from 1 to n. So if it's a 2 here, then it would need to have just one more thing, one more segment here, which would have to be a 1, and there's no 1 here. And they wouldn't equal to the same thing anyway. So this cannot be a 2, and therefore that must be the 3. So that's a 2, 1. Because they must sum up to the same thing, and all the digits from 1 to n must be used. Alright, and now we are pretty close to being done, I would say. 586 is down here, meaning that a 6 is not here. So that's a 3, and that's a 4. 6 over here, 2 on the other side. And that's a 2, 3. So a 3 is up here. And it's a 1. 2, so a 2 is either here or here, meaning that it's not here, so a 2 is here. The 3's are done, so the 4 must be here, and now the 4's are done. 5. So an 8 cannot be here, because there's no 7 or a 9, meaning that that's a 5, 6, so this is an 8. 1, 6. This is the only place for the 1. That's the 2. Let's check the 4, 5, 5, 6, and 5, 6. That's a double, meaning that there is no 5 or 6 anywhere here. So that's a 7, 8. And this is the 9. And 5, 6, 7. So these two are consecutive, so this cannot be a 5. So this has to be a 6, 7, 9, 5, 8, 9, 2, 5, 6, 5, 8, 7, 6. And then this is a 7, 8, 2, 6. And we are done. That was a very fun puzzle, and I think it's a very unique puzzle as well. And I hope you guys enjoyed this as much as I did. Thank you, and see you in the next one.